Hello, welcome to another Random Code live coding stream. This is part 3 of working on the Advent of Code 2025 problems and trying to get all 24 stars. Used to be 50, but this year they've pared down to 12 days, so now it's 24. And I got my coffee going. Let's get my music going. So that's playing in the background. All right. Okay, so in the last stream, I spent time going through the part 2 of day 3. And I think I have an algorithm now that will do it, hopefully correctly. Because again, you can write code that doesn't do anything right, but it still will do something. So let's get into it. So how do we want to do this? Well, we know we need 12 characters, right? So that's your battery bank. And what we want to do now is say var joltage values is equal to a new char of 12, because we know it's got to be 12. Okay. I'm going to keep n here because that's the way I wrote it, is 0. Okay. And we're hoping that the way I write this is that there's always going to be a loop of 12. So we can say here for 0 I less than 12. I guess we could say here, because I already have one magic value here. Don't want more. All right, so as we go through the loop, we take the number in the starting index. We then say var left values is equal to battery bank as span, and then we can just, I guess, take what I wrote here. Of course, we're going to have to change it a little bit because we want the length of the string here minus starting index minus n minus 1. Okay, so that gets us the values to the left. And now what we want to do is find the largest value and its first index, right? So could we do something like left values max? Darn. Yeah, I didn't think you could. This is one unfortunate thing about spans, is that they don't have all of the because I would love to put this in a way so that I could, can we do a new sorted set of char and giving it, could that be left values? No, it, well, what I want, not an I compare, I want That don't work either. I want an enumerator. I do want to avoid allocations, but unfortunately with span, there's really no way to do what I want to do. Even if I put in system link, that's not going to help. Because again, span is not an enumeration. If I remember right. Yeah, there is a library that does things like one called no alloc. So that allows you to do some of the operations that you can do similar to what you can do with jeez, span. So you can do range, repeat, all, any, count. I don't know why they don't have these in .NET proper. So because it would be really nice, especially in a case like this. Because what I want to do is I guess we'd end up copying anyway, right? Because we have the values, what we want to do is find the first instance of the largest one. So if I say here, substring, I'm already getting a well, that gets you substring. Okay, now what I could do is I could say var left largest. We could say left values max. That gets us the maximum value in a generic sequence. Okay, in that case it wants to be a char. The 8 char is going to be bigger than a 7 char, which will be bigger than a 0 char. So that gets us the largest char. Now we want to find left largest index, which is left values first index of the first occurrence. We know it would be in there. Yeah. So now what? No, I don't want to replace. Go. I guess we could say ignore case because these are just going to be numbers. Now what? Why would I want to use contains? No, that... Oh, that's annoying. I know what I want. Okay. So we get the largest character. We know what the index is. So now we can put in at joltage values of I left largest. Okay. N minus minus, because we want to go down one. And then the starting index equals plus equals the the starting index is now equal to, sorry, I had to read my notes. And where we found the index left largest index plus 1. There. So then when we come out of this, that is our biggest number. So we can say as a char, as a sequence, well, I don't think we're going to use maximum joltage here. I think we're going to do int 128 parse. We could now say joltage values as span. There. That should work. Maybe. We're going to find out. Let's go to our tests and do part 2 and put in what the value it thinks for part 2 should be. So if we come here, yeah, I thought that. Now it's going to be that. Let's see. Oh, we're going to have to do int 128 parse. How wrong are we? Does our code have an exception? Does it just not calculate it right? Well, it did something wrong, so... Okay, again, we're close-ish, but we're still not, like, we're somewhat close, but we're definitely not doing the right thing. Fortunately, though, we can probably, yeah, we don't need this. So let's debug. Okay. So this tells us that we should, at the end, be getting this. So let's see what we got. 9888888. Well, that's your problem. That doesn't work. So the left values here, we get our 9876. And the largest one should be a 9. And that is going to be at index 0. Right. Okay. So we put in at 0 a 9. And then we say our starting index is the left largest index plus 1, because we don't want to include 9 anymore. So now we're going to start in index 1. I'm going to go the whole length minus the starting index minus n. And so we get the left values. 8. The left largest value should be 8. And its index should be at 0. Oh, I did that wrong. It's not the index, whoops. It's not the index in the substring. It's the index in the battery bank. Because that's where we actually want to pull it from. Now what do we get with our test? Still failed. It's a little better. What do we get now? 987654321. Is that right? Nine eight seven 65432 and then 1111. Okay, so the first value was correct. What does the second value look like? 8 with a whole bunch of 1s and 9. That's also correct. What's the third value look like? 4, 3, and then a whole bunch of 4, 7, 8. Yeah, that's... So we have a problem with the third value. All right, so let's debug that. So that's 1, 2. Okay, now let's go through this. 2, 3, 4, 2. So we should see the left largest as being 4, and the index of that should be 2, right? Yep. So we get 4. And we're going to start at 3 now. So now we get 2, 3. Because we got 4, that's, and so now we're saying it should be 2, 3. And we should pull out 3 with it being like, no, that's not right. Oh. Slight adjustment. We need to say index of, but at a point at the starting index. Right. So we want to find that character, but we want to start at starting index. There we go. Now what happens? Now we pass. Okay. What happens now when we do this for part 2? We get a value. How bad is it? Yes! We move. We move. Part 2. Bingo. And I have to think the person's name was crazy yesterday. I don't want to get like everything spelled out. I really am trying to, just like if I'm playing a video game that I haven't played before, I don't want to get hints. I don't want to get spoilers. But somebody just threw out something that I think made this a much quicker algorithm than what I was ever going to come up with. I was going to, I think, do a very hard-coded approach to it. And this ends up being much more elegant. Can we please take that out? Yeah, now we can, because we can say we're starting at that index. So that's a little bit easier to read. Not the greatest, but hey, it works. So do we have all of our stuff updated? Yes, we do. Commit. Part two of day 3 is done. All right. So now we can move on to 4. Excellent. Let's go to our advent calendar. We got the 6 stars, so we're a fourth of the way done, right? Because there's 24 total. So let's see how far we can get in 4 with the rest of the stream. And maybe get to even 5. Again, depends on how hard these problems get. So day 4, printing department. You ride the escalator down to the printing department. They're clearly getting ready for Christmas. They have lots of large rolls of paper everywhere, and there's even a massive printer in the corner to handle the really big print jobs. That was actually my first job out of college. I worked at Quad Graphics. That was I think still a printing company. They have a bunch of plants, or they did, in Wisconsin, a couple other places in America. I think they actually had one in Argentina, if I remember right. That was back in the 90s. So I was a programmer. I didn't work on the printing machines, but you'd walk around, you'd see them. So anyway, decorating here will be easy. They can make their own decorations. What you really need is a way to get further into the North Pole base while the elevators are offline. Actually, maybe we can help with that. One of the elves replies when you ask for help. We're pretty sure there's a cafeteria on the other side of the back wall. If we could break through the wall, you'd be able to keep moving. It's too bad all of our forklifts are so busy moving those big rolls of paper around. Oh, great, a maze problem. If you can optimize the work the forklifts are doing, maybe they would have time to spare to break through the wall. The rolls of paper, the ampersand signs, are arranged on a large grid. The elves even have a helpful diagram, your puzzle input, indicating where everything is located. For example, the forklifts can only access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. The hell does that mean? If you can figure out which rolls of paper the forklifts can access, they'll spend less time looking and more time breaking down the wall to the cafeteria. In this example, there are 13 rolls of paper that can be accessed by a forklift, marked with the X. Okay, I'm puzzled by how this puzzled. The rolls of paper are arranged in a large grid. You also have a helpful diagram. For example, the forklifts can only access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. Oh, 8. Okay. Sorry, I was thinking strictly 4. So this is 1. If we're considering this one here, this is 1, 2. So that works. So that's why you see it here. Now the reason this one doesn't work is that you have 1, 2, 3, 4. Okay, what about this one? If I was looking at that one, 1, 2, 3, 4. So that one wouldn't be considered. But this one, 1, 2, 3. So it doesn't wrap around. Okay, so you have to look at all the 8 around it and say, without wrapping, and see, do you have 3 or less? Consider your complete diagram of the paper roll locations. How many rolls of paper can be accessed by a forklift? Now, this is probably going to be, you just literally go across and down, and you say for each position, look at every valid adjacent position. So if I'm like in the corner here, that's 0, 0. I can look at 0, 1. I can't look at like -1. So again, I can only look to see if that value is either greater than or equal to 0, or it's less than the max, the number of lines or something like that. Or it's less than the length of the string. Yeah, so we have boundings. So you can say if that X and Y would be within that, then, you know, and if it's that character is blank or a dot, or the at, you could say the at, and then once you've finished calculating for a specific position, you can then see how many rolls of paper can be asked for forklift. Okay, so this one gives you a test, and then we can use the big one, which is probably going to be a huge file. Yep. Now, there's always the what's the part 2 going to be like. So hopefully there isn't a, like, you have to use some type of optimization on the algorithm I'm about to do. So let's come here. Let's get 3. We'll do 4. Okay, so let's grab all this, grab all that. So we have 140 lines, and the max is like it's 140 lines long, or 140 characters. Okay. All right. So let's get to 4. Actually, we want an immutable array. Let's go to 2 for now. And we know that the max length is, so we can say var min x is 0, var min y is 0, var max x is battery banks 0 length. Because if we have like a 10 character string, the max that x can be is -1. It can be 9. And then var max y is equal to the whole length of the stuff. Okay, let's get this out of the way. Var accessible paper rolls equal to 0. Return that. Now we want to say for var x is equal to 0, x is less than Actually, we want to do it reverse. Hey, genius. For var y is equal to 0, y is less than or equal to max y plus plus. Let's grab that. X is less than or equal to max x plus plus. Okay, so when we do y here, what we want to grab is var line is equal to battery banks of y, because that's the line we're going to look at. So now we need to figure out because that now gives us that, so we need to say var adjacent paper roll count is equal to 0. And then we say if at the end of this adjacent paper roll count is less than 4, then we say excessive. No, that's wrong. No. There. So now we just got to figure out the logic in that inner for loop to say, well, what are your adjacents around it? And as long as we find less than 4, right? Yeah. So the first thing we can do is we can start like at the upper left. So if x minus 1 is greater than or equal to min x, and because we have to do bounds checking, and now we have to go up 2 as well, and say if this is great, that and y minus 1 is greater than or equal, come on, greater than or equal to min y, and actually I want to parenthesize because it's just easier for me to read it that way, even though I think order precedence in C# would take care of it. It would tell me, no, those are necessary, I guess. Otherwise, I'd say you can remove unnecessary parentheses. So if we can go back 1 and up 1, then we can say if now we got to go battery banks of y minus 1, and that's valid because we have determined that we can do that at the character x minus 1 if that's equal to a dot, and let's just make sure we're grabbing, no, we want to do that. If that's equal to this character, then yes, we do adjacent paper rolls. Okay. And so now we have to do this for 8 of these. And there's probably a simpler way to do this, but having 6 or having 8 of them is fine. Okay, so now we want to say if x is greater than that, and we have to go up. Now the battery banks at x, And now we do this, except we say +1. Actually, we don't have to do this check here because we know that we know that x is valid because we're at x, so we don't have to worry about it in that case. Now we need to make sure that x plus 1 is less than max x. Is it less than or equal to? Less than or equal to, I think. Because we're saying we're getting the length here. Actually, let's do this. I think this will make more sense in my little brain. Strictly less than and strictly less than. Okay. Okay. So if we have a length of 40, we'd only want to go up to 39, 0 to 39. So if we were at 39, we did 40, we don't want to access there because that would be wrong. Okay. So these are the top three. Now let's do the left and the right. And then we'll do the bottom three. So the left is going to be kind of like this, except we're on the same line. So we don't have to check Y. Because we're on Y. And that's okay. The right is like this. Except again, we don't have to check Y. Because now we just say Y here. And now the bottom three are going to be like the top three, except pluses on the X's. Well, pluses on the Y's, sorry. So we want to say Y plus 1 is strictly less than max Y. So that's going to be the case there. And so we now need to say plus 1 there. Need to change the case here. We need to say plus here. There. That should do it. Should being the operative word. We could say for the top and the bottoms, we could do the min Y, the Y check on all of them because it's going to be the same. So what we could do is say here, we could say if that, and then pull these three in, but then remove the check on the Y. Like that. This one would always happen. And then we could take this one out of here. So it's a small optimization, but and then we could do the same thing on the bottom three. And grab this and say if, and then we take these. I don't know how smart the jitter would be with this, if it would recognize that as something that it could remove. Okay. So, and this will only happen when you're at the first line, the 0th, and the max bottom line. That's the only times those are going to come into play. So we have y minus 1 on all these, x minus 1, x plus 1. And then we're on the line, we do x minus x plus. Mins and maxes, mins and maxes. Max, min, y, x minus x plus. Okay, let's see how our solution is. So it should be what? 13? Except we need to put in the right input, otherwise we're going to be screwed. Okay, so let's do this. By the way, if you're new to the channel, you haven't subscribed, please do so. I would really appreciate it. And if you've already subscribed, I appreciate you for doing that. I gotta say that once in a while. What does this do? How bad is this? Yeah, it didn't pass. Why is it not coming up with the little helpful thing there? So disappointing. 0. Oh, I grabbed the... You know, it helps. Still failed. Still 0. Oh, and we should, yeah, being stupid. We only want to look to see if the current one is a roll. Because otherwise we don't care, right? We look at this. The blank positions are... So we only want to do this if line of x is equal to an @ sign. Then do we do any of this? We never found any accessible. That doesn't make any sense. Oh, I know what I'm also doing wrong. That has to be for each XY position that we do. Oh, and then we just move that. Right? Still failed. Except now we got way too many. Okay. Well, let's figure out why. Because we should be able to see, hopefully quickly, that as we're going through, what am I doing, Orange Cat? Advent of Code. So adventofcode.com/2025. It's in the description of the live stream on YouTube. So we should be able to see pretty quick, like, this one's valid, this one's valid. But then, like, this one should not be considered valid, so we said 42. I'm curious, what's the var count is equal to input value I am just curious. Nope, 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 nope. Stop, stop, stop. Wrong key. $71. So we're not doing every single one. That's what I was worried about. Well, somewhat worried about. So there's 71 of those in here, but there's only 42. Don't understand. Think of, well, thanks, appreciate it. So we aren't considering everyone, but we do want to consider. We're considering more than we should. I'm not seeing it. Is this C sharp? Yes, it is, Muhammad. Well, I guess no better time than the present to go through this. So X and Y is 0. We know that's not 1. X is 1. We know that's not 1. Now when X is 2, what I'm guessing is that we're getting the correct ones, but we're also getting ones that are not to be correct. So this is 0, 1, 2, 3, 4, 5, 6. We want to see X is 7 because that one, 2, 3, 4, 5, 6, that one should not be correct. Or that one should be one that's considered. So we want X is 7. Okay, so this one, 0, 7. Right? So we should have 0, 1, 2, 3, 4, 5, 6, 7. This one should not be considered. Okay, so it is a paper roll, so we do consider that. Now we say, do we look at the top 3 positions? No, we shouldn't, because that's -1, and we wouldn't want to do that. We look to our left, and there should be a roll there, so we increase the count to 1. And then we look to our right, and there is a roll there. And so we get 2 there. So there was 1 to the left and 1 to the right. Okay. Now we should find 1 to the lower left and to the lower right, and that should give us 4. So this should give us 3 now. And we looked below us, and that shouldn't have given us 1, correct. And so now we're saying we want to look lower right. So that gave us 4. And so we don't count that. Okay. Oh, wait a minute. Wait, whoa, did I? Yeah, that's a mistake. This if is in the wrong place. We only want to do this if our current position is a paper roll. And now we pass. All right, let's do the test. We're going to do 4 on day 4 input. And then we're going to change this to run 4. Is that the right answer? Moving on. We got another star. All right. Now, how is it going to ramp up on the second part? Part 1 of day 4 is done. All right. Let's fill up on some more coffee here. There. Always got to get that recharge. Okay, now are they going to make it help? How are they going to make this worse? Now the elves just need help accessing as much of the paper as they can. Once a roll of paper can be accessed by a forklift, it can be removed. Once a roll of paper is removed, the forklifts might be able to access more rolls of paper, which they might also be able to remove. How many total rolls of paper could the elves remove if they keep repeating this process? Starting with the same examples above, here's one way you can remove as many rolls of paper as possible using highlighted to indicate that a roll of paper is about to be removed, and using X to indicate that a roll of paper was just removed. So your initial state, you find the ones that the forklift can remove, and you remove those. And then you go through the process again. You're like, oh, I could remove these. And so those are removed. And then you go through this and you say, I could remove 1, 2, 3, 4, 5, 6, 7. Remove 7 rolls. Then you can do 5, and then 2, and then you get to 1, and then you can get to 1, and then 1. And then at this point, you can't remove anymore. Because like this one has 1, 2, 3, 4. This one has 1, 2, 3, 4. Like all these have 4 or more. So it's an iterative process on what we had before. And so that's where the fun of this comes into play, is you just have to iterate on what you did. So if we come to our solution here, we can take this and go down to part 2. Now what we want to do is we want to say yeah, it was, for one iteration it was okay, but now what we need to do is we need to create a new map every time. And actually, I have a question in your opinion. Is worth learning C#, like everyone else? Well, not everyone else is learning Python. I don't learn Python. Not to say I should learn Python, but why not learn both? No harm in it. I mean, when you say, is it worth learning C#? I mean, how do you determine worth? Does it get you a job? Probably will. There's lots of places that do C#, that do .NET. Lots of them. You know, are you looking for something local? Are you looking for something that, you know, like I work remotely, so I don't go into an office every day. So location doesn't really matter to me too much. Lots of things you have to look at. So, all right. So we could, well, we would get that it, yeah, we can't quite reuse what we had before directly, because that would just tell us, yeah, there are roles you can remove, but it won't say where. We need to keep track of where now the accessible roles are. We need to have a structure in place. So we need to use the magical point. We don't want to use the point that's in system drawing. No, no, no. We want to have our own point, right? I forget the order of which. Yeah, you gotta do it the other way around. There we go. Okay. So what we want to do now is keep basically going through this until keep going through this until we no longer find paper rolls. So we want to say here, this is a new list of point. Okay. And now what we want to say is do actually, we can move this in here. Do while accessible. Bite me. We're going to start it at the do loop every single time and reallocate it. Now we're going to say accessible paper rolls length count is greater than 0. Okay, and then what are we trying to find? Var total paper rolls removed equals 0. Okay. What am I missing here? Oh. Bro's cooking. Well, I'm trying. I'm trying. This doesn't mean any of this is going to be right, but actually we could do this and just say it's a list of points and then do that and then say that. Yep, because then we wanted it, every time we would come through, we want it to be initialized to this. And so now find all the locations. So we're going to basically copy that thing I just did and change it slightly for what I need. And then we're going to say here, if accessible paper roll counts is greater than 0, that means we still found some, and this will check it. Now we have to update the content. So what this is also going to mean is we're going to want to, we were able just to take the immutable array of strings. Strings are immutable. We can't just go into a string and say, change a character. That it just doesn't work that way because strings are immutable. So what we're going to have to do outside is create a matrix of chars, based on battery banks. And that's going to be our content. Okay, so we got to do that. Then we're going to get a list and we're going to figure out how many rows. So now we go through the loop and we say, let's go find them. We're going to take that algorithm we just did, plop it down in here, and find all the locations, adjusting it so that it's using the matrix, not the immutable array of string. And then we're going to say, if we found any, we still found some, then we're going to say total paper count plus equals accessible count. So those are the ones we're going to remove. So we got that count updated now. We update the content. So we're going to go back through the list of all the locations and say those are now dots, essentially. And then if we did find some, the loop's going to go through again, come back up here, we reset, and we process the map again. Once this comes to 0, we're going to hop out, and we just simply return total paper rolls removed. Okay, so let's now do this matrix thing. So what we want is var battery bank. Oh, wait a minute. These aren't batteries. We can just say this is a map. It's just a map. We could call it a paper roll map. And I should change it up here just because the name, I copied it from the previous problem. Let's use something that's a little bit more... Naming is important. So we want to have paper roll content, we'll call it. And it's going to be equal to a new char of... The x coordinate is going to be max x, and then max y. Now, if this shows you what is the problem? Oh, shut up. I don't want to use a jagged array. And you should. And this shows you how little I use. No. How little I use arrays of more than one dimension. So. All right, so now what we want to say is we want to create the matrix. We got hopefully the size of it, the x and the y, and now we want to say for var x, and we want to say for var y, thank you. So we want to say paper roll content of x comma y is equal to, thank you. So that now gets us our matrix, okay? And it's one that we can update as we need to. So now we need to find all the locations. We're going to take all this. We're going to have to adjust it a little bit. Because now we need to find all the locations. And so we don't want to use paper roll map. We want to use paper roll contents. Except we don't need a line here. We can say paper roll contents of x and y is 0. Okay. And so really everything in here that uses paper roll maps, we can say paper roll contents. There. So what are you barking about? Oh, yeah, the syntax needs to be flipped. One moment, please. And that. And that. And of course, we have to do another change here in just a second. Now we want to say if it was greater than or equal to 4, That's when we, no, I'm sorry. Less than, yeah, it's still less than 4. Except what we want to do is we want to add to accessible paper rolls. Yeah, we don't do this. We add a new X and Y. There. So now that's tracking that we found the right position. And this is still for each individual position. The accessible paper rolls are just tracking the locations. So if we found that we found some that we can remove, now we basically say update that count, and now we gotta go through the content. So we have to go for each var accessible paper roll in accessible paper rolls. And then we just say on the matrix, paper roll content of accessible paper roll X and Y is equal to a dot. It is no longer a paper roll. It has been removed. If we go to our solution day 4 tests and we say part 2 here, and we change this to part 2, what was the right answer? 43. How bad is this? It passed. Doesn't mean it's right, but it passed, at least the small test. So if we do part 2 here, how long is this going to take? I just don't trust myself. Actually, you know what I should be doing? I'll do that in a second. Hold on. You're right, Orange Cat. I was cooking. I was cooking. All right, so let's do a little bit of cleanup here. Let's put the answer in the right spot. Part 2. So let's actually remove when I'm saying these. And so then like some of these if I don't need notes, some of these I did. So let's do that. Let's go. I was just trying to keep track of the value because I didn't want to rerun it again, but yeah, that works. All right, so git commit part 2 of day 4 is done. That was actually that's scary to me because before I say that, just gonna reminder, if you haven't subscribed to my channel, please do so. I would really appreciate it. That one went quicker than any of the others because there has been problems in the past that I've literally spent hours on, and I just could not find the solution. I finally did. Like the year 2022, I got all 50 stars, but there were a couple that were like, oh my god, they were so. They just took me forever to get my head around. This one, fortunately, was not too bad. So, thanks for the sub. Appreciate it. All right, let's look at 5. I still got some time. So we are now what? 8 stars out of 24. We're a third of the way there. So we have to keep going down escalators and elevators and all this other stuff. Let's take a look at what 5 is. Cafeteria. As the forklifts break through the wall, the elves are delighted to discover that there was a cafeteria on the other side after all. You can hear a commotion coming from the kitchen. At this rate, we won't have any time left to put the wreaths in the dining hall. Resolute in your quest, you investigate. If only we hadn't switched to the new inventory management system right before Christmas, another elf exclaims. You ask what's going on. The elves in the kitchen explain the situation. Because of their complicated new inventory management system, they can't figure out which of their ingredients are fresh and which are spoiled. When you ask how it works, they give you a copy of their database, your puzzle input. The database operates on ingredient IDs. It consists of a list of fresh ingredient ID ranges, a blank line, and a list of available ingredient IDs. For example, 3 to 5, 10 to 14, 16, 20, 1, 5, 8, The fresh ID ranges are inclusive. The range 3 to 5 means that ingredients 3, 4, are all fresh. And that's important. Ranges are important to know if the beginning and ends are inclusive or exclusive. The ranges can also overlap. An ingredient ID is fresh if it is in any range. The elves are trying to determine which of the available ingredient IDs are fresh. In this example, this is done as follows. Ingredient 1 is spoiled because it does not fall in any range. 5 is because it falls in the 3-5. 8 is spoiled because it falls in the 10-14. Yep. 17 is fresh because it falls into 12-8 as well. Yeah. And then 32 is spoiled. So in this example, 3 of the available ingredients are fresh. So let's do our puzzle input. I'm going to try something. I'm going to say 4, 5, just so that we have it. Okay, so let's grab all this, put it in there. Okay, so let's get our solution day 5 file up. Okay, and we don't have a part 2 yet, and this one doesn't have a point, so let's just start here. Okay. Now, what we could do is just capture each range. Bro, what in binary is this? What is this? Like, what do you mean, what is this? This is Random.Code. So, I don't know what you mean by what in binary is this. The problem? Or what? So what we could do is just keep all of the ranges around and then just look at all the numbers and say, are you in any of these ranges? Because if you're in a range, then you're good. You're fresh. Okay? So many numbers, only numbers. Yeah. That's very typical of, Random.Code, has these kinds of problem setups. They're meant to be somewhat simplistic and not language exclusive. They want to be language inclusive. It doesn't matter what programming language you want to use. You should be able to parse this out. To find all the ranges, I just keep looking for a string that has a dash in it. Once I find an empty string, then I know the rest of them are IDs, and I can just capture them that way. So what I can do, though, is instead of having 4 here, you notice that the 12 overlaps here. Okay. So we could try to collapse all these and just say, how many ranges do we really need to keep? Because at the end of the day, we only need to keep 2 ranges, 3 to 5 and 10 to 20. Now we could just keep how many ranges there are going to be here. So if you look at this, well, I can't see it here, but if I go back to the file and I move down, there's only going to be, what, 176, 100, whatever, 77, whatever ranges. And to say, is this number in this range? Is this number in this range? It would maybe behoove us, because like you can see right here, this, maybe it's hard to say, you know, which ranges might be in other ranges. But if you go back to the problem, like I get 3.5. Okay, then I get 10.4, and I could say, is that in any previous range? Nope, we've got two exclusive ranges. More about the algorithm. The algorithm is going to be fairly simple. You just go through the IDs, you go through all the ranges, and you say, is it within that range? And then you come into here and you say 1218. And so you start going through and you say, well, could that be part of this range? No. Could it be part of this range? Yes. Okay. So now you can do that. Now you'd have to look at all the rest of the ranges and say, can they be put into a previous range? And does a previous range now fit? Because this could have been like this could be like 18 to 20. And so when you see this one, well, that would have gone into that one. I don't want to say the ranges that are coming in are ordered in every way. Anyway, what I'm trying to anticipate is reducing the amount of ranges that we have to look at. And I think I can use a package that I have created, maybe, to make this work. Okay. So let's clear out this, because that's the previous one. And we want to say, we'll call these we'll call this the database, because that's what they're calling it in the program. C# is more fun though, more like C++. To some degree, there are some things in C++ that you can do that, you know, go beyond what C# has. But for the most part, yeah, I haven't done C++ since 2001. So I don't remember like hardly anything about that language anymore. So what I could do, let's give this a try. Let's come here. Now I said I wouldn't pull in just arbitrary packages, but this is one that I've created. It's called Spackle, and it doesn't really have much in it these days. But we could say now we'd have to do something like this though, because the ranges in my package that I have here are exclusive by default. And because just I wanted to pick a just some kind of standard to use. Now if we look at our input, if we look at the longest ones here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, That's a long, especially a U long, would probably be more than sufficient for what we need. I'm just trying to think of a way to get the ranges to compact in a quick way, if that makes sense. Let's just start going through we know we're going to have var ID ranges. So we're going to have a new list of ranges of ulongs. Okay. And we also know that we're going to have ID ingredient IDs. And that's going to be a list of just ulongs. Okay. So now we're going to do for each for our item in database. And we're going to say if the item string item.length is greater than 0, so it's not the empty string. If item contains a dash, you don't like that. Ah, fine. So if it's a dash, this is a range. Else, this is an ID. Okay, so here, this is the easier one. We can say ingredients, add a ulong.parse of the item itself. Okay. The range is going to be slightly more difficult. We need var start is equal to, well, we want the parts. The parts are going to be the items, thank you, split. Okay. And so now what we want to do is say ID ranges, add a new, where the start value is going to be ulong.parse of parts of 0, culture info, current culture. Okay, so that gets us the start value, but now we need the end, and we need to make it inclusive. So we need to add 1 to it. And we need it to be 1. There. So that at least parses the content out. Okay. And what are we trying to find here? We're trying to find fresh. Var fresh ingredient count is equal to 0. And that's what we're going to return. Okay. So at least we'll shut up the compiler for a second. Now what we want to do is we have the ID ranges and we have the ingredients. So we want to say for each var ingredient ID in the IDs. If ID ranges any. ID range contains the ingredient ID. It's fresh. And that's done. Now this is not as performant in the sense that, again, we haven't compressed the number of ranges. We could do that so that we end up having our for each on line 36 there a little bit less work every time we go through. Well, every time we do the any, there'll be less ranges to look through. Let's just see if this works first. So let's go to our test. And then let's come up here, 5, part 1. Okay, and now we need to grab this as the input. And so we should find 3 doing it this way. It worked. For the test case, it worked. So what about my program? So we're going to do on day 5. Part 1. Make that 5 and make the file 5. Okay. Okay, so what did 5 give? Is it 756? We don't know yet. Cooking. All right, so we got 5 done. Git commit. Part 1 of day 5 is done. Now, again, you can say I cheated. I did see, though, that there was a... if I come into here and I say var x is equal to new range, it represents a range that has start and end as indices. Okay. And this thing here, this is what you use when you're doing the dot dot syntax within arrays or collections, so that you can say I want to go from 1 dot dot 4. You're actually using a range that has indices in them. That's not what my range is. My range is more of like a mathematical range, if that makes any sense. And so, and this range is also generic. So if I go to this, it's equatable, it's parsable, it's span parsable, which is nice. You can give it a range here. If you forgot about that, I wrote all this and I forgot about all this. You can union them. See, that was the thing I was going to bring this in, is because you can shift them. So you can shift and get a new range. The ranges are also immutable, so you can't like change the one that you have. You can intersect them. That's another reason I brought this in, because then we can do that. We can parse, and the parse I need to add comments here, obviously, because I forgot. Oh, that's how I do it. So you have to put it into this format, so it's not the dash format. Should there be a default for parse convert when you don't have to specify the code? Yeah, there is. But because of the way I code, I have treat warnings as errors. And so those comes up as just warnings. You don't have to include them. I just do. And so then I put those in there. So yeah, you don't have to do that. And then as you see, it annoys me because then I could also put those in here as no warns and then say, nah, I don't care about those for this, but whatever. It's my standard and I suffer by it. I thought there was a time maybe back in 1 or 2 where code wasn't so ugly. How is that ugly? What's ugly about this? What are you talking about, guy? Come on. If I'd had that off, then yes, none of this would matter. Okay. And if you look at this, it says it's 1307. If I go to that, this should be it's for clarity. That's all it is. And it's just a warning. I could just suppress it. So I am just choosing, it's just extra noise. I mean, yeah, and especially for advent of code, you can argue and say it's just extra noise. I guess, I don't know, whatever. The thing that comes to mind, and the reason why I do this with culture, is I was on a project in, God, when was that? 2003, 2004, something like that. And it was actually a C# WinForms project. And what they wanted to do is, it was basically to show like images of finger. It was a security type of program, and so they wanted it to you would show fingerprints, actually handprints, and then show them on the screen and show images of them, and then they have annotations on them. But their first client, I think, was the language is going to be Arabic, and Arabic is right to left. So yeah, WinForms had right to left capabilities, but they were kind of half baked. That project was a very big eye opener to me in terms of, if you want to make a program international, and again, this was what, almost 20 years ago at this point. Just saying right to left at that point was not good enough, because there were some things that it did that weren't exactly correct. Plus, what we had to do is, if you had an image up on the screen, we couldn't just right to left the image. We couldn't flip it around, because that would have been incorrect. We had to show the image as is, but if there was any annotations of text on it, that had to be right to left. So that was, we actually found a rendering bug in WinForms with all the work that we were doing. So that was fun. And I think the reason I bring that up is that kind of made me a little bit more cognizant and aware of internationalization in programs. For something as simple as advent of code, you could say it doesn't matter, and yeah, you'd arguably be correct, and that's fine. But I still kind of default to this because, not everybody speaks English, and I don't know, I just decided to keep it there anyway. So in any event, we did get part 5 done, and I did commit that. Part 1 of day 5. I don't know if I'm going to have time to do part 2 of day 5, but let's at least take a look at it and see what kind of progress I can make on it. Part 2. The elves start bringing their spoiled inventory to the trash chute at the back of the kitchen. So that they can stop bugging you when they get new inventory, the elves would like to know all of the IDs that the fresh ingredient ID range is considered to be fresh. An ingredient ID is still considered fresh if it is in any range. Now, the second section of the database, available ingredient IDs, is irrelevant. Here are the fresh ingredient ID ranges from the above example. Are 3, 4, 5, 10, blah, blah, blah. So in this example, the fresh ingredient ID range is considered to be a total of 14 ingredient IDs to be fresh. Yes, so I was on the right track going, we had to do something to compress the ranges down, right? And once we have the unique set of ranges, to find this value should be simple, because we can just take, for example, for 3.5, ours is actually going to be 3.6 because we need to make the end exclusive. But then what we can do is just take the end minus the start. And that's 3. Because 6 minus 3 would be 3. So once we can figure out how to put all the ranges together in such a way that we know we have a unique, non-overlapping set of ranges, we've got the answer. So let's see how far we can get. I don't know if I'm going to get all the way there, but now if you didn't have this type, this would be a little bit harder, right? Because you would have to do what hopefully my range type is going to let us do. Okay. So what we want to have here is something like, we don't need the ingredient IDs anymore, right? We can take that part out. Like I said, we want to get a list of all the ranges first. And we're skipping now what we want to do is we want to say fresh valid ID count is equal to 0, right? That's what we really want to do. So let's get rid of this because that's kind of irrelevant at this point. So we're still going to get the ranges. Now, how could we do this? Well, if we take take the first one and then try to put it into any of the ranges that are there. And if you ever find that it could intersect with a range, we want to intersect them. And that's one thing. If I look back on this range type, it does have an intersect. But we will return a nullable range if it couldn't intersect. So we already have the range. We already have the logic in here. See, again, this is where I said I was not going to use like other libraries. I did get the code to do the factors in the previous stream, but I could have figured that out at some point. But this one takes, I think, a little bit more time, and I'm just like, well, I wrote this code, so for me, I find this is valid. Why rewrite the code that I've already done? So we could go through each one, and then we say, can this intersect with this? No. Can it intersect with this? No. Can it intersect with this? No. Okay, so we're still stuck with this. Now we take the second one. We don't have to look at the previous ones because it would have, like if this would have intersected with this one, what? That's not what I meant. Stupid browser. If it would have intersected, we would have replaced this with the intersection and we would have removed this one that we're looking at. Okay. So now if you look at 1014, does it intersect with 16 and 20? No. Does it intersect with 1218? Yes, it will. We're going to get a 1018. So then what we'll do is we'll replace this one with the intersection and we'll remove this one. Okay. Now we go to this one. And so we can't use a for each because we're going to be editing the array as we go through this. And so we say here, does it intersect with this? Yes, it will. And so again, as soon as we find one that intersects, we stop. Okay, and we might find other ones later on, but that's okay. I think that should work. We're going to see. Maybe not. Guy, you'll tell me if I'm totally going down the wrong path. Maybe, because I don't want backseat driving, but having help is fine. So yeah, we want to go through these, but we also want to change the indices of where we're looking if do you have a lot of unit tests for this range class? Who do you think I am, guy? Come on. Seriously. Seriously, guy. Come on. Jeez. Do I have unit tests? You're so funny. You're such a funny guy. Spackable. All right. So let's see. Oh, there's a project called tests here. There's range tests. Oh, look at that. Look how many tests we've got. Oh my goodness. Do I have tests? Oh, I'm insulted. Oh my goodness. All right. Anyway, I'm trying to, again, when I do coding streams, I try to keep them PG. So, when I'm gaming, oh, it's totally like whatever language I want to use. But when I'm doing these live streams for coding, I do try to keep them a little tame. So smile. Yeah. So we're going to have to keep track of the one that we're changing, and then we want to remove that one. So we have to be a little bit careful because we will start bringing the size of that list down. So we want to we want to compress the ranges, and then we want to calculate, calculate the counts. Now this one we can do. We can say for each var ID range in ID ranges, because assuming that that's going to have all the compressed ones, we can now say valid ID count plus equals ID range end minus ID range start. And again, this will work because the end is exclusive on my range. We have already adjusted them for the +1. What is the problem here? Oh, it needs to be a U long here. There. Oh, and then we need to do a U long here. Okay. This is just this middle part. That's the part that we need to be careful about. So we want to say for 0 I less than ranges.count I plus plus. But we have to be, well, do we? Yeah, we do. Because if we remove one, it's going to be the one that we're on. And so then we're going to want to, like, say I minus minus so that it ends up on the right thing, even though we plus plus it. And I don't remember if a for loop captures the count and doesn't read it dynamically as you go through stuff. Because that's actually important in this case. If the for loop captures this condition and doesn't calculate it dynamically, we're kind of screwed. We'd have to come up with a different way, right? I'm going to go with it should be reading this every time and not just saying that's a capture, but that might be an incorrect assumption. And that's a puzzler question. What will happen? Well, we're going to find out. So we want to get var target ID range is equal to the range that we currently have there. Now what we want to do is we want to say for var j, because I can't think of anything is equal to I, j is less than ID ranges count j plus plus. Because now we want to go through the rest of them and say, you know, if we want to say var ID intersection is equal to the target ID range intersect with ID ranges at J. Okay. If ID intersection is not null, no, I forgot. What is the range? Is it a struct? Yeah, it is. So should this test right with structs nullable? Yes. I forget, or if I have to look at has value, I keep forgetting. If we actually did an intersection, then what we want to do is we want to say ID ranges at J is equal to ID intersection value. I can't remember if this is going to work. We're just going to say, does it have a value? If it has a value, then we can say yes. The whole nullability thing and structs and classes, I feel like sometimes is somewhat disjointed, but whatever. It is what it is. So if we got a new intersection, great. But now we need to remove the one that currently exists. The one that we've intersected with, because we don't want it around anymore. It's now part of the merge of these two. So we want to say ID ranges remove at the index that we're currently at with I, subtract I, and break. That should break out of the for loop here. So if we found like the 0th one that got merged with a third one somewhere down the list, we say, okay, replace that third one. We removed the 0th one. Okay. But if we didn't do this I minus minus, what would happen is we would come out of the array and we'd actually skip, because we would have taken this out. If we would have merged it with this, now I being 1 is actually going to be this one, and we don't process this one. So we have to jump back. And that's why these ranges and the counts are actually very important, because we don't want to skip these. At least in my mind, that's what's going through my head. So if we do part 2, let me say part 2 here. Now what do they say? There should be 14. Yep, failed. 14, but was 0. Yes. Awesome. All right, what did we do wrong? Let's start here. And by we, I mean me. I'm just trying to be inclusive here, just like ranges. Intersection inclusion, you know. So how many ranges did we get? We got 4. 3, 6, 10, 15, 16, 21, 12, and 18. Yeah, again, it's the right ones, except they're off by, you know. So we look at the first one. Target ID range is 3 to 6. Now this shouldn't ever match with anything else, right? So we come into here, did this intersect. Oh. Off by 1s. We don't want to start at the same, at least that's one bug. We got 11 this time. Okay, that's better. We found one bug. So now we're going to look at J should be 1, right? Yep. Does it intersect? No, it doesn't. So I want to see ID intersection is not, no. Oh, ID. Yeah, that would work. Okay, fine, whatever. Does it have a value? No, it doesn't. Okay, so we come through this again, and the range is 4, right? Does it intersect? No. Does it intersect? No. All right. So we jump out, and now we do I++, and so we're going to look at I being 1. This is the 10 to 15 one. And this will intersect with the last one. So the first one it should not intersect with, right? Because we're on J2. That should not intersect, and it doesn't. But this one should. 12 to 15. Oh, crap. Wait a minute. I'm using the wrong thing here. This is giving you the intersection between the two. It's the union we want, not the intersection. Yeah, I think that's what we want, is the union, not the intersection. The intersection just gives you I should have, actually that's a good thing to do. This is one library I should come back to and add like more comments to this. Because what intersect does is it says what's like the smallest between the two of them, and say that's your intersection. So if you think of like two big groups, it's the Venn diagram, it's the middle part. We want all of it. That's what we want, I think. That passed. Okay. So what happens when we do part 2? We get a bigger number, which is to be expected, because, but is that correct? We are grooving and moving. Boom. Part 5 is done. We got 10. We're almost halfway there. But we still got a ways to go. So let me remember real quick. Part 2 of day 5 is done. All right. I do need to stop very soon. I'm just going to look at 6. I want to see what's in store for tomorrow, which I am going to stream on Christmas Eve and probably Christmas Day too, because I got nowhere else to go, and we don't just sit around doing nothing on those days. So I will probably do more streaming tomorrow and Thursday, and maybe Friday, or probably Saturday, and more of that. Let's just take a look at what 6 is, and then I'll stop. So this is the trash compactor. After helping the elves in the kitchen, you were taking a break and helping them reenact a movie scene where you over-enthusiastically jumped into the garbage chute. There's a lot of movies that do that. Resident Evil does. A brief fall later, you find yourself in a garbage smasher. Unfortunately, the door has been magnetically sealed. As you try to find a way out, you're approached by a family of cephalopods. They're pretty sure they can get the door open, but it will take some time. While you wait, they're curious if you can help the youngest cephalopod with her math homework. Oh, so that just links to another day. What is the other day? snailfish. So if you really wanted to, you could do that, I guess. Whatever. Cephalopod math doesn't look that different from normal math. The math worksheet, your puzzle input, consists of a list of problems. Each problem has a group of numbers that need to be either added or multiplied together. However, the problems are arranged a little strangely. They seem to be presented next to each other in a very long horizontal list. For example, this. Each problem's numbers are arranged vertically. At the bottom of the problem is the symbol for the operation that needs to be performed. Problems are separated by a full column of only spaces. The left-right alignment of numbers within each problem can be ignored. Okay, makes sense. So this worksheet contains 4 problems. That times that times that. That would be plus. And then that times that times that is that. And that's plus. To check their work, cephalopod students are given the grand total. They're adding together all the answers to the individual problems. In this worksheet, the grand total is that plus that plus that plus that. Of course, the actual worksheet is much wider. You need to make sure that you unroll it completely so you can read the problems carefully. So this is a parsing problem, right? Let's look at the puzzle input, which of course, yeah, we can't even scroll out to see the whole thing. But we basically need to parse this out. So, and as you see here, these are these, yeah, they're all, I think they're all spaces. So we could do a regex and say, remove all the spacing. So that's one space. So there'll have to be a way to play with this, but let's just make the day 6. Let's get it set up. Let's get it started. So I'm going to say day 6 here. Okay. And then we're going to grab all this and put it in here. And so yeah, now you can see it's actually like it looks more organized this way. But if you look at line 5, yeah, there we go. So now you can see it. So human-wise, oh, this would be easy to do, but we just have to parse this out so that we get the right values for everything. And the thing that we'll know is that once we get a row of like X values, we know that everyone after that is going to have the same exact one because they all need to align. And then we just need to look at the bottom one and say, do you multiply all these together or do you add them all together? I say this is going to be simple, but I know myself better than that, right? So let's make this day 6. 6. You can see this is a worksheet. And then we're going to say here, this could get rather large. So I am going to use good old big integer. Var answer is equal to big integer 0. Well, thank you. Return answer. There. All right, so we got a starting point. And initial setup for day 6. Save and commit. Push. All right. So again, I'm going to stop here and I will probably be doing a stream tomorrow in the morning again and continuing work on this. So the goal will hopefully be to get to, if I go look at my calendar again, the goal will be to at least get to halfway. And then we'll see. I can look at all the rest of the problems because they're all open at this point, but I'm not going to do that. We're going to try to get 6 done. And then we'll see how 6 part 2 ramps it up. And then we'll look at 7. So the goal tomorrow will be to at least get 6. And then let's see how far we can do with 7. So, but we're almost halfway. And I'm enjoying this. I'm having fun. Primarily because I haven't hit something yet that has completely thrown me off the rails. yet. I'm sure it's going to happen. So I want to thank everybody who's been watching either now or in the future. If you haven't subscribed to the channel just yet, please do so. I would really appreciate it. If you've already subscribed, I appreciate you doing it. I may do a Halo stream. I have a karate lesson from 2 to 3 today. So I might do one after that or after dinner tonight. I'll see. It depends on how things work. But I might do a short-ish Halo Infinite stream. But I'll be back again with Random.Code and Halo Infinite tomorrow. Real quick, I stepped away. Did the ranges compress down considerably? Okay, I will look at that real quick. Because I really don't know. Let's go to program. We're on day 5. So let's go look at day 5. And let's get rid of all the breakpoints that we have already. So let's look at what we had here, and then let's look at what we had here. So if I run this, we started with 177, and we went down to 85. So about half. That's roughly a half. But the problem is that if we didn't do this, we'd get inaccurate counts. We basically have to do this, because then we'd have to say, well, did we already do a part of these numbers within a previous range? So even the size of it doesn't matter. It's the correctness that matters, if you want to think of it that way. But anyway, I am done with this stream. Again, thank you all for watching. Take care, and I hope to see you in the future.